Hello. I want to invite you to think of media as geology. Digital media not as something light, immaterial, almost magical. Content in the cloud, information flowing freely, invisible infrastructures. But instead, about minerals, extraction, energy, logistics, toxic residues, planetary time scales, and deep histories that long precede humans and will likely outlast us. This lecture moves from the symbolic to the geological, from interfaces to infrastructures, from screens to the earth. Did you know that producing a computer weighing 2 kilograms requires a staggering 800 kilos of raw materials? Or that the energy required for Bitcoin mining reached more than 140 terawatt hours last year, which is more electricity than it is consumed by most small countries. Media do not exist in the air. Every digital action, a message, a video stream, an AI query depends on physical infrastructures, natural resources, and continuous energy flows. These systems are not neutral or purely technical. They are ecological and political. All digital hardware relies on minerals extracted from the earth, lithium, cobalt, silicon, while every file and stream is sustained by mining, energy production, and planetary cycles. Copper cables and fiber optics form the nervous system of the Internet, and lithium has become the oil of batteries, essential for phones, laptops, and so-called green energies. In this sense, the future of digital culture reactivates older colonial and destructive dynamics. At McLuhan's Global Village, access is uneven. More Africans today have mobile phones than access to drinking water. So a simple question remains. When you open a video on your phone, where is that file physically located? Media are always embedded in material systems. Neolithic peoples settled in fixed communities during the Holocene, around 10,000 years ago, following the retreat of the glaciers. These communities gradually developed into cities, creating the need to store grain and plan for the future. This process led to a distinction between the human and the non-human domains. With industrialization, energy sources shifted to coal, oil, and gas. The 19th century is characterized by the exploitation of nature and the modeling of the environment through mining and coal-based energy. Steam navigation, railways and telegraph, and the opening of rivers to navigation became part of the productive forces of this era. Modernity is inseparable from energy regimes. The economic order has been, from the beginning, an energy order. Lewis Mumford identifies two major periods. The Paleotechnic era, characterized by coal mines and their social and aesthetic consequences, and the Neotechnic era, defined by electricity and the application of chemistry to industry and agriculture. Modernity brought not only machines, but also chemicals. Peter Sloterdijk identifies the beginning of the 20th century as April 22nd in 1915, when the gas regiment used chlorine gas in the Flandre in Ypres. Thousands of years of cultural techniques for manipulating soils came to an end with the First World War and nitrates. Wars and technologies dream of being ahead of their time, says Hitler. The Anthropocene must be interrogated as a condition with profound consequences for the horizon of our historical understanding. Data centers form the industrial core of digital culture. They are vast infrastructures where data is stored, processed, and circulated continuously. Despite the rhetorics of the cloud, these systems are anything but immaterial. Data centers are physically massive, permanently operating, and extremely energy intensive. They require enormous amounts of electricity to power servers, continuous cooling systems to prevent overheating, and vast quantities of water for thermal regulation. In turn, they generate heat, carbon emissions, and significant local ecological pressures. Recent research from Global Energy Monitor shows that gas projects in the US pipeline explicitly linked to data centers have increased almost 25% over the past 2 years. The cloud does not float. It is grounded. Digital media are directly connected to mining. Geology transforms into media. The materiality of media begins long before media becomes a medium. A 22 nanometer transistor contains indium, gallium, and arsenic. A single microchip can contain 40 to 60 chemical elements. Your smartphone is a portable geological archive. Lithium, cobalt, silicon, indium, gallium, rare earth. We carry small pieces of Africa in our pockets. Not metaphorically, literally. The digital is not clean or light. It is dense, metallic, and extracted from the earth. Your smartphone is a stratigraphic object. The geological fragments we transport are not just pieces from Africa, as I just said, but include material from the Red Dog mine in Alaska, where zinc ore is extracted and later refined into Indian oil in Canada. Its polished surface hides toxic labor conditions and ecological damage. Digital devices are chemically toxic. Electronic waste contains lead, which causes damage to the central and peripheral nervous system, the blood system, the kidneys, and the reproductive system. Cadmium that accumulates, for example, in the kidneys. Mercury, which affects the brain and kidneys, as well as pregnant women. Chromium, which is capable of crossing cell membranes, producing multiple toxic effects in contaminated cells. Barium causes cerebral edema, muscle weakness, and damage to the heart and liver. Those who suffer these effects are rarely the users, but factory workers and informal recyclers, often in the global south. The Anthropocene names humans as a geological force, reshaping both the earth and its environment. Some theorists, however, propose the term Antropobscene to expose the hidden and obscene underside of this transformation. At stake is a fundamental shift. The geopolitical has become geological. Control over digital infrastructures increasingly means control over the subsoil. Rethinking the Anthropocene, then, is not only an environmental task, but a challenge to how we understand history and its future horizons. Media time is linked to processes of mineral formation and energy infrastructure. The minerals that make digital devices possible formed over millions of years. The media have a history that is not only human or technological, but planetary, a notion described through the concept of deep time. Media time is linked to processes of mineral formation and energy infrastructure. Two other important concepts within this framework are hyperobjects by Timothy Morton, which are massively distributed entities in time and space, such as climate change, nuclear waste, or the biosphere, that are so vast and complex that they exceed direct human perception and understanding. The other concept is zombie media. According to Jussi Parikka, zombie media refers to obsolete or discarded media technologies that persist after their supposed death, either through reuse, repair, hacking, or as environmental residues such as electronic waste or obsolete satellites orbiting the Earth. Let's be very clear. The cloud is not a metaphor. The cloud are servers, cables, cooling systems, electricity, water, and heat. And then we cannot forget the planned obsolescence and electronic waste. According to Bernard London in 1936, the economic recession was prolonged because consumers continued to use and reuse their devices. Thus, the state should impose a tax on products that remained in use behind their predetermined lifespan. Although these ideas were never fully implemented, they went on to inform industrial processes that we are still seeing nowadays. Last year alone, 400 million electronic devices and appliances were discarded in the United States. Around two-thirds of them were still in working conditions. The cloud hides, but abstraction is political. The Gaia hypothesis describes Earth as a self-regulating metasystem, balancing atmosphere, temperature, ocean pH, and the global circulation of organic nutrients such as nitrogen, sulfur, and potassium. Our understanding of this planetary equilibrium, however, is inseparable from media technologies. Climate models, satellite imaging, and long-term data series make these processes perceptible. Visual media give form to scientific concepts, rendering planetary dynamics visible. From the first images of Earth, seen from the Moon, to deep space observations through the Hubble telescope, media reveal what would otherwise remain invisible, including these temporal processes unfolding across vast scales. Without technological mediation, phenomena like global warming would not be perceptible as such. Yet media do not only reveal planetary processes, they also leave materials and environmental footprints on their own. Visibility in this sense always comes at a cost. As Bruno Latour argues, nature and culture are inseparable. A geological approach to media reveals the impossibility of separating the social from the natural, or the political from the geological. The supposed immateriality of the digital is grounded in electricity, minerals, infrastructures, waste, and toxins. Media are therefore material systems operating in deep time, with lasting environmental and political consequences. The media infrastructures and debris we leave behind may become our only monuments, readable as future fossils. The Earth already bears these chemicals and technological traces as an archive of human activity. Some, like plutonium-239, persisting for tens of thousands of years. There is a paradox in the scale between the individual human and humanity in shares of 1 to 7 billion. 1 grain, another, 3 grains, 4. At which point does it become a pile? So I leave you a question. When do millions of micro-actions become a global transformation? Let us begin by looking at the world beneath the interface. Thank you.